Welcome, Huskies. We're going to go ahead and do day 5 today. To do this well, you're going to go ahead and need to make sure that you have your calculator ready, and it is in degree mode because we are going to use a little special right triangles and some SOHCAHTOA today. So this should be a continuation of day 4. So we should also know that the area of a regular polygon meaning that all sides and angles are congruent. So that's why these are special polygons. But the area is going to be 1/2 the apothem times the perimeter. And we're just going to go ahead and shorthand that to 1/2 little case a big P. It's a little big P because it represents a formula. So what we're going to do today, and I'm going to go ahead and look at our example here just for a second. We're going to be missing a piece. So in day 4's notes, you had the apothem, and then you had the half side. Well, notice here the apothem is missing. And there's not enough information for you to go ahead and just use our Pythagorean theorem, and that's what today is all about. So that's going to be the nuts and bolts. So what we're going to look for is a central angle. The central angle and the radius all come from the idea of circles, the unit we just finished. So if I were to draw a circle around this, we're going to go ahead and see that right here produces a central angle and its arc. So there's going to be a bunch of those, but that's why it's a central angle. So the angle where the vertex is in the center. So the radius is going to go from the center to a vertex of the polygon. You should have done that yesterday. And you can see that right there. And then obviously we have the apothem. And then we have the half side and the side. Pretty self-explanatory. But I'm going to go and erase this for just a minute so we can focus in on this triangle. So I'm going to highlight this triangle here in blue. And this is a right triangle, okay, because the apothem is going to be perpendicular to the side. So that means that we can use our SOHCAHTOA if we need to find anything. Or we can use special right triangles. It's up to you. So here are the steps. So step number 1, you're going to go ahead and find the central angle. So to find that central angle, that's going to be the number of sides. So we're going to have the number of sides. Excuse me, I have that backwards. Sorry, friends. It's going to be 360 degrees divided by the number of sides. Oh, Mr. N, I'm writing in pen here. You're killing me. So it's 360 divided by n. Okay? So step 2 is you're going to make a right triangle, and then you're going to fill out what you know. So in this right triangle, I'm going to go ahead and draw an example. That's a horrible triangle. But this side right here is always going to be your apothem. Always, always, always. This side down here is always going to be the half side. And this side right here is always going to be your radius. And then this is always going to be our theta. That's going to be the angle we're going to use. So the reason why we do the central angle is that once we have the central angle, you're going to go ahead and make this right triangle. Step number 3 is you're going to find the half central angle, which is going to go right here. And we'll show you that step in just a second. And then step number 4 is you're going to use SOHCAHTOA or special right triangles to find your missing sides. And then step number 5 is you'll do the area is equal to 1/2 AP. So ladies and gents, those are our steps. You can go ahead and pause or rewind if you need those, but let's jump into it. So if I were to look at this and try to do this at the start, it would be 1/2 apothem times the perimeter. Well, I could find the perimeter because this right here is a half side. So that means this is also that half side. So this is 4, meaning the sides are 8. So my perimeter would be 6 sides at 8 apiece, which is going to be 48. But what I am missing is this apothem right there. So here's the steps that we're going to go ahead and do to find that apothem. So first I'm going to find my central angle. So I'm going to draw in my central angle, and that's going to be right there. So it's 360 degrees divided by 6 sides, so it's 60. So that's 60. But this right here, this is an equilateral triangle. This equilateral triangle is great, but I can only use SOHCAHTOA with the right triangle that we can see right here. So what we're going to do is find the half angle. So for the half angle, that's going to be the central angle divided by 2. So 60 divided by 2 is going to be 30. So that's going to be 30. So if I were to, and I'm a fan of redrawing this triangle right here. So this is 30, this is 4, and I need my apothem. So let's go ahead and label this. This is opposite, adjacent, hypo. And so if I do my SOHCAHTOA, I'm going to go ahead and realize I have my adjacent and the opposite. Adjacent and the opposite is tangent. So we're going to do the tangent of 30 degrees. It's going to be 4 over A. Put this over 1. Now, we should be good at doing this in the calculator, but just in case, if you get out a calculator and you go ahead and do tangent 30, that's our answer. And it's negative. If you get a negative, it's in the wrong formula. So make sure your calculator's in degrees like what we see right here. Then if I try it again, tangent 30, I'm going to get 0.577. Okay, so we need that. So tangent, oh, sorry. So from here on out, I'm going to do those calculations on a calculator, but just so you know, that's how we did it. And now we're going to cross multiply. So 1 times 4 is going to be obviously just 4. And then A times that 0.577, 0.577 times A is going to be 0.577A. And then we're solving for A, so we're going to divide both sides by that 0.577. And then, again, just going to throw that in any old calculator. So I'm going to make sure my is in the right degrees here. And I get A is 6.928, excuse me. So now I have my apothem, and I'm going to go back all the way over here. So my area is 1/2. The apothem, which we just found, is 6.928 times 48. And then we just go ahead and put that in the calculator. And I went ahead and I got 166.276. And this is going to be centimeters squared because it's area. And that's our answer. Cool with that? So, ladies and gentlemen, that's how you're going to go ahead and do this one when using our SOHCAHTOA. The next one I'll show you is using our special right triangles, just to show you that you have different options. Special right triangles are a little bit faster, too. So, in this case, if I go 1/2 apothem times perimeter, I have the apothem. That apothem right here, highlighted in purple there, is 6. But what I need is this half side so I can find the whole side. So I'm going to draw my right triangle. 360 divided by 6 sides is going to be 60. So this is 60. But I want half of that. So if I divide that by 2, this is going to be 30. All right. So if I do that triangle just right here, this is 30. This is 6. And I need this half side. I'm going to call that X. So you could use SOHCAHTOA again, and if you want to, go back and watch the previous example. But on this one, I'm going to use my special rights. So this right here is the short leg because it's opposite the 30. And then this would mean that is going to be, I'll do this in a different color, 60. So this is going to be the long. And when you go short to long, you just multiply by root 3. So that means, excuse me, I'm going the opposite way. Sorry, friends. I went the opposite way there. At least we caught it before we went too far. I'm going long to short. So I'm dividing by root 3. And then it's okay to have a decimal. So go ahead and get that decimal. 6 divided by the square root of 3 in a calculator is going to give us 3.464. So that's our x. Done. That's a lot easier. And if you times it by 2, because this is going to be 3.464, and this is 3.464, meaning the side is going to be 6.928. Oh, good. That's a lot easier. You didn't have to do any SOHCAHTOA. That's, again, why we showed you those special rights. So back over here, my perimeter is going to be 6 sides times 6.2928. So if I put that in the calculator, I get 124.708 inches squared. Boom shakalaka. Alrighty, moving on to this next one here. In this one, they gave us the radius. So when they give us the radius, that's the bummer because that means we have to find the most stuff. So we're going to start with our central angle. So that's 60, and we know that because it's 360 divided by 6 sides, which is 60. But I only want half of that, so I'm going to divide that by 2, and so that's 30. Is it always going to be 30? Well, it is if we keep having these hexagons, but if we have other shapes, then no. So this is 30, this is 12. I need my apothem, and I need my half side. So again, I like using special right triangles. So this is going to be the short, this is the hypo, this is the long. And if I'm going hypo to short, I just divide by 2. So that means this is going to be 6. And then if I go short to long, that's times root 3. So this is going to be 6 root 3. Boom. We're already done. So now I know that this is 6, this is 6. So that's going to be 12, that's going to be 12. And then this apothem right here is going to be 6 root 3. If you would prefer the decimal, because our answer probably will be a decimal anyways, that's going to be 10.39. Cool? So now plug it in the formula. Area is equal to 1/2 apothem, which is 6 root 3, times 6 sides at each one is 12. And if we put that into our calculator, I'm going to go ahead and get 216 root 3, or if you want to find out what that is as a radical, I'm going to get 374.12, and that's going to be millimeters squared. Easy peasy lemon squeezy, friends, when you know your special right triangles. All righty. So we have a couple more here. We'll use number 5 special because that's a different shape. But why don't you try number 4? Hit pause, give it a shot. All righty. So ladies and gentlemen, here's our central angle. This is 60. We got it because we did 360 divided by 6 sides, which is 60. Now I want my apothem. So if I just draw that in, and so I'm going to go ahead and say, all right, the apothem, I don't know, but I know the half side is 6 and 6 because that's going to add up to 12. So if I make my special right triangle, ideally you do this in special rights, but since I did the last 2 in special rights, how about I do this one in SOHCAHTOA? So this is how we got. And technically on this one, you could even use Pythagorean. Oh, we don't know that that's 12 yet. Sorry. Yet, my fault. So on this one, we definitely have to use our SOHCAHTOA. And it looks like we're going to use tangent again because this is the opposite and the adjacent. So tangent of 30 degrees. Why is it 30? Because it's 60 divided by 2, which is 30. So tangent 30 over 1 is going to be opposite over adjacent. So we do tan 30. And I get 0.577 again. Over 1 is equal to 6 over A. Cross multiply here, and I get 6. Cross multiply there. That was the worst circle ever. But 0.577A. And then I'm going to divide both sides by 0.577. And then when I put that into the calculator, I get A is going to be 10.39. Okay, so I get 1/2 my apothem, which is 10.39, times 6 sides at each one is 12. And I got 374.13. And then what are our units here? Feet squared. Alrighty. So, ladies and gentlemen, our last one here is a triangle. And this is going to be our central angle here. So that's 360 divided by 3 sides, which is 120 degrees. So that's 120 degrees. Well, I want half of that, so if I divide that by 2, I'm going to get 60, and that's my theta right there. So my apothem is 2, but I'm missing my half side. You can use your special right triangles again if you really want to, and that would be nice because we have a 30, 60, 90, and this is x, and this is 2. So to go from short to our long leg, or to medium, however you want to describe it, it's just times √3, and so this is going to be 2 √3 for our x. Now, if you want to go ahead and put that in a calculator, you like the decimal, then you do you, and that's okay, but that's going to be 3.46. So this will be 1/2 my apothem of 3.46, or 2 √3, and then, excuse me, my apothem is 2. Lordy, don't make these videos at the end of the day, friends. So that's 2. And then my perimeter, because if we take a look at this, this is that, not a race, circle. This right here is my half side. So this is 3.46, and this is 3.46. So if I add those together, I'm going to get 3 times 6.92. So if I go ahead and I multiply that by 3, then times it by 2, then times it by 1/2, we're going to get 10.39 feet squared. Alrighty, friends. So the kicker was special rights or your SOHCAHTOA, but those are our examples for today.